All right, now I want to actually work through the Evel Knievel problem that we had in class, just so that we have that down, and just so that we are kind of moving forward with our review session next time, so that you guys can review this tonight in case you had an issue with trying to figure this out. So let's say we have this motorcycle that's moving along here. Let's see here. It was moving, if I remember correctly, it was moving at 40 meters per second. It's going to hit a ramp that was at 30 degrees and had a height of 5 meters. And I wanted to figure out what his maximum height was going to be. And I didn't really care where he landed. Maybe he crashed and things didn't work out so well for Evel Knievel on this attempt. So this is what I'm trying to find. Interesting thing about this is it doesn't matter what the mass of the motorcycle is and so on and so forth. And we're assuming that as it's traveling up the ramp that we have no static or kinetic friction force. I know we talked about rolling friction before, and that's as a tire rolls on a surface, it stays in contact, therefore it's static friction. I'm just going to assume that there's no friction either in the bearings or worrying about drag force, or he's skidding and therefore he's kinetic friction and so on and so forth. So he reaches the bottom of the ramp. He's going 40 meters per second, which is close to 100 miles an hour. And his velocity is going to decrease because he's going to accelerate in this direction as he goes up the ramp, and then he's going to come off the end with some initial velocity, which is going to be the final velocity for as he accelerates in the negative direction up the ramp. And then that is going to then tell me what his maximum height is by dividing this up into its two components, Vox and Voy. And when we're now a projectile, the only acceleration, or only force on Evel Knievel is Fg, which gives us an acceleration of, in this case, we'll say 10 meters per second squared, negative, in the downward direction. Okay, so how are we going to first break this up? First, we're going to look at Evel Knievel, which I will just now draw as a block on a ramp. And I know that this is 30 degrees. So I end up with all of my forces. I end up with Fg. I end up with Fn, and there is no friction force, so I don't have to worry about that. Divide my forces up into Fgx and Fgy. So that is to say that I have divided them up into these two components. Actually, what I should say is I divided them up into these two components, saying that this direction is the positive direction, and the x direction, y. So I'm going to go right to the x direction. Sum of the forces in the x direction is equal to ma. And I end up with, let's see, Fgx is equal to ma, Fg sine theta. Remember that this is my angle, theta up here, so that's 30 and this is 30. So sine theta, because it's the opposite side, is equal to ma. Mg sine theta is equal to ma. So we can cancel these out. So it could be Evel Knievel, or Evel Knievel on this with his twin brother, or Evel Knievel on this motorcycle that's really heavy, or a very light motorcycle. So we end up with an acceleration that's equal to g sine 30, and we know sine 30 is 0.5, so we have 0.5 times 10, so my acceleration is going to be equal to 5 meters per second for every second squared. Okay, so now what we're going to do with this is we're going to treat this as Evel Knievel now goes up this ramp, where this is 5 meters, and this right here is 30 degrees again. So now he's starting at the bottom with a velocity of 40 meters per second. It's an assumption that I have to make. And at the top, I want to know what its velocity is. So that's going to be my V final here. So, and it's going to be in the same direction as the ramp is. So now I need to know what this side is. Well, I know if this is half of the hypotenuse. So therefore, this is 10 meters. So I want to find the final velocity. I don't know time. I do know the distance, and I do know the acceleration. The acceleration is in this direction. So then I end up with a v squared is equal to v naught squared plus 2a, and I'll just write this as delta x, assuming that this is still the x direction. So my final velocity, that's what I'm looking for. My initial velocity is 40, 5, and 10. So here we go. I have v squared is equal to initial, which is going to be my 40 squared plus 2 multiplied by 10. Ooh, 10? No, not 10. 5. So this is actually a negative 5. It's in the opposite direction. Multiplied by 10 meters. Let's see here. Can I do this in my head? No, I can't do this in my head. So I'm just going to say that I find what my V final is. It's equal to something. All right, so then what I'm actually going to do with this is this V final becomes my V initial for my projectile. So I'll just draw this down here. 30 degrees. I break this up into the x and the y components. So this is my V initial from right here, which is this value right here. And then I end up with V naught x, which is equal to V naught cosine theta, and V naught y, which is equal to V naught sine theta. Well, I'm trying to find the maximum height, so I'm really concerned about the y-axis. So I'll just pick on the y-axis. So with the y-axis, I could say that I know, well, let me do it the way that I've done it before. What do I know in the y-axis? I know that my v initial in the y direction is equal to v naught sine theta. That's a known. My v final in the y direction at the maximum height is 0. As if I throw a ball up as it reaches the maximum height, its velocity goes to 0 meters per second. My y initial, where is it initially? It's at 5 meters. My y final, that's what I'm trying to find. My acceleration is negative 10. It's in free fall. So let's see. Do I have everything? Oh, time. I don't know time. Well, do I have an equation that's independent of time? Sure, I do. I just use that same equation up here. So I end up with Vy squared is equal to V naught y squared plus 2a delta y. So now I'll solve for this, and I know that this is 0. I know that this is 10. So I have 0 is equal to whatever my V initial y squared is, plus, now I have negative 20, negative 10 times 2, delta y, and I'll solve for delta y. Recognizing that delta y is the distance, this is 5 meters, from here up is my delta y, my change in my y displacement. So therefore, whatever I end up for my delta y, I'll have to add 5. So it'll be delta y plus 5 is going to be equal to your maximum height. And there we have it.